Now let's do some problems connected with work, energy and power. Let's say I have thrown a particle of mass m is equal to 2 kilograms with an initial velocity of 20 meters per second vertically upwards so that it raises to a height h and where the final velocity becomes 0 at this height. So who all are doing work? I am doing work because I have thrown the particle upwards, and gravity is doing work because the velocity is becoming 0, it's changing the velocity. So two things, myself and the gravity, both are doing works. So let's see what work I do. I did a work, I supplied an energy is equal to 1/2 mv initial square. This is what I did, nothing else. This is my work. So which is equal to 1/2 times 2 times 20 whole square, which is equal to 400 joules. This is the energy I supply. Okay, this energy when it goes here, this kinetic energy is becoming 0, but it's converted into potential energy. So what is the potential energy that converts into the work done by gravity will be equal to mgh, so which is equal to 2 times 10 times h, which is 20h. So this work done and the energy I supplied both are same, because energy can neither be created nor be destroyed. Whatever energy I supplied in the form of kinetic energy is getting converted into potential energy here. So equating them, both of them, 20h must be equal to 400. So h is equal to 20 meters. So the body raises to a height of 20 meters. So the work done by me is 400 joules, that is I supplied that energy, and that is converted into potential energy and stored here. Again, the energy stored here is potential energy, and that also will be equal to 400 joules. Okay. Now what time does it take to go up? Time taken, t is equal to root of 2h over g. This we learned in acceleration due to gravity chapter. There we have thrown a particle upwards and we came to know the time taken to raise to height h until it becomes final velocity of 0 is this one. So this is the case. So on substituting the details, root of 2 times 20 times over 10 gives you 2 seconds. So we got 2 seconds as the answer for the time taken to raise to this height. So the power that I supplied is power is equal to work done, which is 400 joules from here over time taken. Time taken is 2 seconds. So which gives me 200 watt. And this you should write it as small letters, that is WATT, or you have to mention it capital W, just like capital J. So this is your power that I did. What about the power done by gravity? Power is equal to how much? The same power, because the 400 again, the potential energy converted is this one over 2. So the power what I supplied is being utilized by the gravity in raising to height h. So that's how we do problem with power, work, energy. So let's see another simple example. Let's say a mass of 2 kilograms, let's call it as m1, moving with an initial velocity u1 equals to 5 meters per second, strikes another mass of 1 kilogram, which is at rest initially, u2 equal to 0. This is m2 mass. So this goes and collides this one. So after collision, let's say they stick together and move together. Then we, using conservation of momentum, we have finally, if both of them are moving together, is m2, m1 and m2 together, they're moving with a velocity v, then we know m1 plus m2 times v equals m1 u1 plus m2 u2, which we learn in conservation of momentum. So we did it a collision problem in a similar way. So m1 plus m2 is 3 kilograms, 3v equals m1 u1, which is 2 times 5, plus m2 u2, which is 1 times 0, which gives v is equal to 10 over 3 meters per second. So from 5 meters per second, the combined masses are moving with 10 over 3 meters per second. Okay? So now what did we learn? So the initial kinetic energy initially equals 1/2 m1 u1 squared plus 1/2 m2 u2 squared. On substituting u2 is equal to 0, this becomes 0. We remain with this one, which is 1/2 m1, which is 2 kilograms, u1 is 5, which is 25 here because u1 squared. So this becomes 25 joules. This is the initial kinetic energy. What is the final kinetic energy? Kinetic energy final equals 1/2 m1 plus m2, both masses together with the final velocity v squared, which is equal to 1/2 times 3 kilograms, 2 plus 1, v squared, which here is 10 over 3 whole square, which we get as 1/2 times 3 times 100 over 9. So this 3 cancels 3 times, so you get 50 over 3 joules, which is 25 joules. This is 50 over 3, which comes to be 16.66 joules. So from 25 joules to 16.66 joules, the kinetic energy has come down. But according to conservation of energy, energy should neither be created nor be destroyed. So the mechanical energy has been destroyed here. So is the conservation of energy true or false? Conservation of energy is true. But in this case, whatever is the loss will be converted into sound energy, heat energy, etc. So when two bodies collide, sound is produced. So when sound is produced, something like this comes and collides. You can hear the sound. So the loss of kinetic energy is converted into sound energy. Similarly, heat is produced. So sometimes a spark is produced, sometimes the temperature raises, etc. etc. So this is what about work, energy and power. Alright? See you in the next class.